Hello and welcome to our presentation about our paper CharacterGAN, Few-Shot Keypoint Character Animation and Reposing. This is joint work by Adobe Research and the Knowledge Technology Group from the University of Hamburg in Germany. I am Tobias Sins and let's get right started. So usually animating a character is a lot of work. So assume you're given a couple of images like these, which you may get from online sources, and to go from these images to an animation, traditionally you have a couple of options. You can either draw the additional intermediate frames, which is a lot of work and requires some skill. You can do some traditional video frame interpolation, but for this you will need more frames than we currently have available usually. Or you can just use traditional approaches to warp the image in 2D, but this will have problems with modeling occlusions or body parts moving in front of each other. So instead we introduce a new model that is basically trained on these images. So we define a set of key points and layers, and we will go into more details on that. And then we train a conditional GAN. And with the resulting model we can animate based on key point interpolation or freeform reposing. So what does our approach look like? Simplified, we simply start with a couple of 2D images showing the character in different poses, and then we label those images with key points and layers. In our case, we always use front, middle and back as the different layers. Based on this, we then will train our model, and we will go into more detail on the next slides. And once we have our model trained, we can use it for animation or reposing based on the key points that we have defined. So this is a high-level overview of our model, and here you can see what we mean by layering. Because instead of training our model on the full input image, we actually split our key points into the different layers. So here you can see the 3 different layers corresponding to the 3 sort of layers front, middle and back. And we will have a different part of the network process each layer independently. And once we have representations for all 3 layers, we actually concatenate them and then do some upsampling to produce the final image. And we show that this approach greatly improves the quality once you have occlusions or like different body parts moving in front of each other. So how do we do the scaling? It's actually quite straightforward. Basically it's very similar to Spade in that we extract a global representations of the layers, and then we have some element-wise scaling and of the features, such that basically you could imagine it could zero out features that are blocked by body parts that are to the front, and we will keep the features of the body parts that are in the front. So if the arm moves in front of the torso at this location, the model would zero out the features of the torso but keep the features of the arm. So let's look at a couple of results. Here you see animations of our model for different characters and how many training images we used. And you can see we really only use very few training images, 8 to 12 on average, and for some characters we use 15. So here are a couple of examples on characters with 2 legs. We can also do this on animals that may have 4 legs. And you can see overall the results are really great, even though we sometimes only use 8 training images. So let's have a look at the benefits of using our layering approach. Here you see the result of our model when we do use a layering approach, and you can see that the individual body parts are well defined and we have no artifacts. However, when we use the same model without layering, you can see that the model fails to model individual body parts, especially when they move in front of other body parts, such as the arm moving in front of the torso. Of course, our model can also be used to animate real humans, and we compare this here to a couple of recent human reposing baselines. So the first 2 baselines fail completely since they were trained on the fashion dataset, which does not contain the poses that we use here for a walking human. The next model is also pre-trained on a large-scale dataset, but is then fine-tuned on our training data, and as a result performs much better. Finally, our model performs the best of all of them, even though it is only trained on 15 training images, but you can see that it does a much better job of modeling the walking human. Thank you very much for watching our video. For more results and details, please check out our paper or our poster, and you can also have a look at our GitHub, where we have the code to implement our approach, as well as more animations and examples. Thank you very much.